Hello everyone. In today's session, we will talk about algorithms and the ways to write an algorithm. Whenever a problem is to be solved with the help of a machine, we have to basically develop its solution. And in order to get an efficient solution, the algorithm has to be written properly. So, an algorithm is a well defined set of steps, that is, a computational procedure which will process some value or a set of values commonly known as inputs so as to produce the desired output, which can again be some value or a set of values. For example, if we wish to find the sum of two numbers using a machine, then a possible step-by-step procedure goes like this. Take first number as an input, take second number as an input. After that, add these two numbers and then finally give the result as an output. This is a very simple example. In a similar way, one has to write algorithms to solve big complex problems. There are certain characteristics that a good algorithm should possess, and they are definiteness, which says that each and every step of the algorithm should be clear without any confusion. Algorithm should terminate for each and every case of the allowed inputs. That is, it should have finiteness. The input accepted by an algorithm should be properly defined. Similarly, the output generated by the algorithm should be clearly specified. Lastly, the algorithm should get executed correctly in real time. That is, it should have effectiveness. The ways used to express algorithms are flowcharts and pseudocodes. Flowcharts uses various symbols to represent algorithms graphically. Complex logics can easily be documented with the help of flowcharts. There are various symbols used in flowcharts to show several things. A few are discussed here. The start and end of flowcharts are marked with ovals. Arrows signifies the flow of control. CPU processing is shown with the help of a rectangle. Parallelogram is used to represent input taken from the user as well as the output to be displayed to the user, and diamonds are used to show conditional flow. That is, the path to be followed is dependent on the condition being true or false. There are several other symbols which are used in flowcharts, and here we have just introduced a few. Those who are interested, they may explore the same. There are three programming constructs. They are sequential, selection, and iteration. Sequential signifies no branching. One has to follow these steps one after the another in order to get the task done. Next is selection, usually shown with the help of a diamond, which we have just discussed. There are only two possibilities and one has to be selected based on the output of a condition. Lastly, there is an iteration where a block of statements have to be executed till the specified condition results in true. These three constructs are represented as is shown here. For sequential construct, symbols are arranged one after another as per the required execution order. The selection construct makes use of a diamond to check a condition. It should have exactly two outgoing paths, one for true and another for false. The iteration construct has a condition such that till it remains true, some steps keep on executing. To represent this, a back arrow is there from the end of a block to be repeated to the point where the condition gets started. So, if we have to draw a flowchart for getting sum of two numbers, then there will be an oval to start. Then a parallelogram comes to take input from the user. After that, rectangle, it represents addition of two numbers, which is a part of execution. Lastly, output is displayed with the help of a parallelogram. Then the flowchart ended with an end oval. Another way to write an algorithm is with the help of pseudocode, where the whole process to be followed is written in a systematic manner using a combination of simple, well-known language, say English, and high-level programming concepts. If we again take the same example of adding two numbers, then the corresponding pseudocode goes like this. First, we will give some name to the algorithm. Here we have given sum of two numbers followed by the list of input arguments. Since we are adding two numbers, we have to use two variables num1 and num2 in the input argument list. After that, we have to clearly specify the input and output. Here we have written that num1 and num2 are two numbers and output will be a sum of these two numbers. Next comes the actual steps to be followed. Now the first step is we just have to compute sum and then return that sum. So it's just a two-step algorithm. However, the algorithm can be complex too. Basically, the thing which one should keep in mind while writing a pseudocode is that it is more structured in comparison to a simple language but less formal than a programming language. Like we need not to follow a syntax of any language, but various programming constructs like if else, if ladder, loops of all kinds, that is for, while, do while, then indexing of array elements or using dot and arrow operator to use class or structure members can also be utilized while writing a pseudo code. One can use return statement like we have just used in the previous example. Similarly, function calling can also be used. Overall, we can use all the programming language constructs formally without following the strict required syntax. We will end this topic with an example now. The problem to be solved is finding maximum element in an array A having n elements. The name of the algorithm is array max element with input arguments capital A and capital N, where A is an array and N is the number of elements in A. The output will be the maximum element in A. Now the steps to be followed are: take a variable max and initialize it to 0. Then iterate over the loop from I equals to 1 to n minus 1. In each iteration, check if the element at index position I is greater than the current maximum at index position max, that is, if A max is less than AI or not. If A max is lesser, then update max to I at line number 4. Finally, when the loop terminates, the maximum element is found at index position max and A max is returned. A variation can be we can return the index of the maximum element. So in that case, we have to return only the variable max. But here we are returning the element. Now the flowchart. It starts with an oval, that is the start oval, and then we have to first take all the n elements of an array from the user. So we have used a parallelogram for that. After taking all the inputs, we have to initialize a variable max to 0, and then to iterate or for the for loop, we have to initialize a loop variable, which in this case is I, to 1. And after this, we have to implement the iteration which we are using in this algorithm. So here we have to first check if the value of I is less than or equal to n minus 1 or not. That means if it is true, then we have to execute the for loop. So accordingly, if the condition is true, we will check the value at A max. If it is less than the value at position I, that is A of I. If maximum element is lesser, then we have to update the max variable to the new max value, that is I. So if the condition is true, we have to update max to I. In another case, if maximum element is greater than the element at position I, then the condition will give us false. Accordingly, we have to use another flow and it will make an update to the value I only. Also, if we are updating the max, in that case also we have to update the value of I. Once the I gets updated, we have to again check if it is satisfying the criteria for the execution of loop or not. If it is not satisfying, we have to terminate. Otherwise, we have to execute these steps again. So for that, we have a back arrow from the end statement within the loop to the condition. Then there should be a false associated with this condition. So in case of false, we have to actually return the max because it signifies that the loop is terminated. We are there with the maximum element and its index, it is stored in a variable max. So if the loop terminates, we have to return max. So we have used a parallelogram again here. And then finally, we have to end the flowchart with the help of end oval. So that's it for today. In the next session, we will look that in order to solve a particular problem, there are more than one possible algorithms available. Out of those algorithms, we have to pick the efficient one. So basically, we are going to talk about the ways with the help of which we can judge which algorithm is better as compared to the another one. So that category, it is actually the asymptotic notations which we are going to discuss in the next lecture. Thank you.